Take a deep breath, kids. Gotta be getting close to summer. Gotta be getting close to summer for you. I hope so. Keep working hard. Don't quit. I don't care how difficult it gets. Drink some coffee. Anyway, here we are. We're going to be doing January 28th, 2014. This part is part 1. And we're going to be doing problems 1 through 14. Aren't you excited? Well, I am. And look, if you can see the time. I don't know. I can see I can move. It's 4:50 in the morning. Yeah. Ooh, I'm excited. How about you? Hope it's not 4:50 in the morning where you are, because if it is, you probably screwed up. All right, here we go. Let's get started. Oh, by the way, just a quick reminder. If you haven't done this work and you're here just to cheat, shame on you. Bad child. Don't cheat. The only thing you're going to do is cheat yourself, and this summer is going to suck because you're going to fail the test. And if you take it again, don't cheat. Do the problems, then come here and see what you can do, all right? All right, none of the lecturings. Let's get moving. I don't know. Let me get my pen. Let me get a good pen. All right, so looking for the common difference in the sequence. Oh, let's see. How do I get from 2A to 4A? I add 2A. And if I add 2A again, I get 6A. And if I add 2A, I get 8A. So it's not negative 2A. That doesn't even make any sense. And then to go from 1 to 4, I add 3. Oh my goodness. Woohoo! That was a tough one. Alright, look kids, I'm just going to remind you. Negative exponents right here. This negative exponent. This negative exponent. Whenever you see a negative exponent like that, the first thing you do is for a fraction, and then take the entire thing, whatever's to the negative exponent, and it goes to the denominator. So if there's nothing left over, the numerator is a 1. And then I end up with 3x squared to not the negative 1, but the positive 1 now. But I don't really need to draw a positive 1. So that's really just to the 1th power, or just, I don't need to draw it. So it's 1 over 3x squared. Wow. Another difficult problem. All right, composition of functions. You could see this problem one of two ways. Sometimes they'll go g of h of x, or they'll write it g of, in this case it's negative 8, h of negative 8. Either way, you're do the closest first. The closest first. So we're going to do h of negative 8. So all I got to do is do 1/2 times negative 8 minus 2. Would I suggest you use your calculator for this? Yes. Just as a triple check to make sure you don't screw up. But seeing as I'm a resident genius, I won't do that. This is negative 4 minus 2, which is negative 6. So that's what h of negative 8 is. Now I'm going to take it and put it into the g function. G of negative 6. So 1/2 of negative 6 is negative 3 plus 8 is 5. So far so good, kids. Not too bad so far. All right. For some reason, I don't know why, we don't like radicals in the denominator. There's two kinds of radical problems. They could have asked you this problem like this. What is 1 over radical 11? When you see something like that, you should be like, woo, smile. Those are pretty easy. You just multiply by radical 11 over radical 11, and you get a radical 11, which is 1 times radical 11, all over, and then square root of 11 or radical 11 times radical 11 is just plain old 11. But that's not what we have here. What we have here is this obnoxious fraction, 1 over, and I'm going to put this in parentheses, 7 minus radical 11. Well, what we want to do here is multiply by the conjugate. Well, the conjugate is 7 plus radical 11. 7 plus radical 11. These are conjugates. All right. Well, the numerator is pretty easy. It's just 7 plus radical 11. I wonder if, so I'm going to guess it's probably 1 or 3. all over. Now, this one's requires a little bit of work. We're going to do 49. Now, if you remember correctly, this would give me positive 7 square roots of 11, and this would give me negative 7 square roots of 11. They cancel. And then I got to think, okay, what is negative radical 11 times positive radical 11? Well, negative times positive is always negative, and a radical 11 times radical 11 is just 11. So the denominator turns out to be 38. Ka-chang! Page 3. Alright, so we got this complex fraction. I'm going to do this. A over 1 plus B over C all over D over 1 plus B over C. And I've always taught my students, I said, my students, if you see a complex fraction, that's a whole lot of fractions on top of fractions on top of fractions, all over on top of fractions on top of other fractions. Find the common denominator. What is the common denominator? Well, in this case, the common denominator clearly is just C. So what we're going to do is we're going to take everything and multiply it by C. Well, let's see. Let's see what happens to the C's. Nothing happens here. I just end up with AC. Here, the C's cancel, so that's plus B all over. Here, nothing happens, so that's just DC plus, and the C's cancel here, and that leaves me plus B. There's my answer. Oh, I apologize. I didn't realize that was a minus. Minus. So AC plus B over CD minus B. There it is. Ka-ching! Done! This high school cafeteria has 5 different lunch periods. The cafeteria staff wants to find out which items on the menu are most popular. So they give each student in the first lunch a list of questions to survey in order to collect data to represent the school. Which type of... So, are they looking at the kids to see what they eat? No, they're not looking. Do they have one group doing one thing and one group doing another? No. Are they asking everybody? No. Are they asking just certain people? Yes, so it's a sample survey. If they asked every kid that came through lunch and gave them a survey, then it would be a population survey, but that's not what they did. Which represents both onto and one-to-one. All right, onto means all of those in the range will be used. So let's see. Let's figure out onto. This one, not used. Can't be this answer. Okay, now we're done with onto. Now, one-to-one means every input has exactly one output. Let's see. Let's see. One output, one output, one output, one output. That looks like one output. That's not one-to-one. That's just telling you about the function. So all of the inputs, where did my mouse pointer go? There it is. All of these inputs only have one output. So that works. And all of these have only one output. These, here, this is a problem. This is going to the 4, and this is going to the 8. It goes to 2 different outputs, so that can't be the answer. So now we're down to these 2. Well, one-to-one means that I'm going in this direction, I only have one output. And then when I come, if I do this in reverse, then these will only go to one place. Well, if I take 2 and go backwards, that goes to H, and it goes to M. That's a problem. Here's your answer. Notice each on the right, on the left, go to only one on the right, and each on the right go to only one backwards to the left. That's one-to-one, backwards and forwards. And all of them are being used. Wow, what a mess I just made of that entire problem. But I hope you get the idea. All right. Max solves a quadratic equation by completing the square. He shows this correct step. What are the solutions to the equation? Well, if you remember correctly, The next step is to take the square root. And if you also remember correctly, when you take the square root, you put a freaking plus or minus. Otherwise, you're not very smart. Plus or minus. So I get x plus 2 equals. Now, what is the square root of negative 9? Well, the square root of 9 is 3. And the square root of negative under a radical is I. So this is plus or minus I. Now when I bring this negative 2 over, I'm going to subtract it. I get negative 2 plus or minus 3I. Ka-ching! Alright, so hopefully they tell you there's 11 letters. So if they were all different, it would be 11 factorial. They are not all different. I have 1A, 2 A's, 2 factorial. I have 1M and 2 M's, 2 factorial. And I have 1 T and 2 T's, 2 factorial. And you got to remember, it's not adding, it's multiplying. There's your answer. It's multiplying. If $5,000 invested at 3% interest compounded quarterly, what is the value of the investment after in 5 years? Use the formula A equals the principal 1 plus rate over number of times we... All right, so we're going to import it. We're going to do it quarterly. So N is going to be 4 because there's 4 quarters in a year. My interest rate, R, is going to be 0.03. I'm sure one of those answers is probably, if you use 3, it should be at least. And my principal amount is 5,000 G's. So what I'm going to type into my calculator is 5,000. Oh yeah, and my time is 5 years. 5,000, 1 plus 0.03. It's in get investment, so all over 4 times 4 times 5. NT. I got my calculator. I do 5,000 parenthesis 1 plus control division 0.03 over 4 raised to the, and I'm just going to do 20 because that's what 4 times 5 is. 5805.92. 5805.92. Choice 3. Alright, when you're talking about real, rational, unequal, equal, blah, 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 you are looking at the discriminant. B squared minus 4AC. That's what you're going to do. I'm going to show you a graphical way to do this too, just because I'm that kind of guy. So, let's see. Now, maybe what I ought to do is write this in standard form or in general form or standard form, whatever the heck they call it these days. 2x squared minus 9x plus 4. This is A, this is B, and this is C. So let's see. B squared is 81 minus 4 times 2 times C, which is 4. 16, 32. 81 minus 32, I believe, is 49. I should probably double check that. 81 minus 32 equals 49. Now, 49 is one of those special numbers. First of all, it's positive, so we don't have imaginary roots. It's not 0. If it was 0, I would have equal roots. It is not 0. So now we're down to these. And for these, it will always be these if it is greater than 0. This is 0, this is less than 0, and these two if it's greater than 0. So the only difference is this idea of rational versus irrational. And since I can take the square root of this, and the square root of 49 is, you can take the square root of almost any number, but I know what the square root of this is. It's 7, really nice. That means the answers are going to be rational. So number 2, choice 2 is your answer. Another way to look at this problem is to do it graphically. If I were to look at this problem graphically, sorry, I'm going to look down. It was 2x squared, 2x squared plus or minus 9x plus 4, and I did it graphically. Well, that's kind of hard to see. Looks like I got a nice root there, and that might be like a half there, might be, I don't know. So I would have to do menu, let's see, trace. How about we just do trace, graph trace, and I just go to the right. Oh, look, a 0. Look at that, 0.50. That's a rational number. And then if I go to the other one, 0, 4, comma 0. Now, if that was irrational, you'd see like a whole lot of crazy decimals there that you don't even recognize. That would be irrational. If this was a quadratic that was, you got imaginary roots from. Let me show you an example of a quadratic that would give you imaginary roots. Excuse me. I don't know why I did that, but whatever. How about we do? All right, I got to make one up. X squared plus 4x plus 6. Oh, there's one. That's got it. See, notice it's up here. It's like floating in space. It never hits the x-axis, therefore there are no roots. That would be imaginary. Oh, and if you wanted an example of one that would be equal, I'll show you an example of one that would be equal. Tab, we'll hit the up arrow. Let's do... I think this would be equal. Yeah, there it is, equal. So what happens is, notice there's only one root. It hits the x-axis just once. That would be an equal roots. Okay. Beat that one. On to 12. Page width. All right. Varies inversely. Here's what I tell my kids. This is, this is one of those things. If I see varies inversely, that means as one goes up, the other one goes down to keep the same product. It equals the same number. Well, what I like to tell my kids is when you see a problem like that, that's two quantities multiplied, x times y, is equal to two other quantities multiplied, x times y. I don't care what those are. It could be pizza boxes and delivery drivers for all I care. Well, whatever, you got to find out what the two things are. Well, in this case, the two things are actually t and d. So I should have used maybe t times d equals t times d. It's not proportional. Proportional means I'd set up two fractions. It varies inversely. So 20 times 2 is equal to negative 5 times, let's see, looks like t. It looks like we're looking for t. So this is 40. So 40 equals negative 5t divided by negative 5, and I get negative 8. That's it. Sine A is negative. That means it's going to be ending in quadrants 3 or 4. In this case, 4. So all I want to do is draw a triangle in quadrant 4. Always start your triangle from the origin, come out, and go to the x-axis. Let's see. Sine is opposite over hypotenuse, which is 25. Now, you've probably done this exact fraction 10 times this year, but so it'll be 7 squared, which is the same as negative 7 squared, plus x squared, which is this is x, equals 25 squared. I refuse to go through that work. I assume you can do it. I know you have to do a Pythagorean theorem. You turn out this is 24. So what is tangent? Well, first of all, I know tangent in this quadrant is not positive. It's negative. All students take calculus. So tangent's positive here and tangent's positive here. So it's negative. All the answers are negative. And it's opposite over adjacent. 7 over 24. Choice 2. Alright, we're to the last problem, chillin'. Well, no, I'd normally say let's just punch this into your calculator, but of course they decide to be jerks and not allow that. I'm going to show you could. I'm going to show you how to cheat. I am loving cheating. I'm just kidding. So here's what we're going to do. We're going to do n equals 1, n equals 2, n equals 3, n equals 4. Because this could clearly be a part 2 question, and you should be able to show it using it this way. So if I put in a 1 for n, that would be a minus 1 squared, or a minus 2 squared, or a minus 3 squared, or a minus 4 squared. Well, doesn't that mean write it twice? I'm going to do it once, and you're going to see this pattern develop. So this really means a minus 1 times a minus 1. Well, isn't this just a squared minus 2a plus 1? If I do it again, a minus 2, we'll double distribute that. I get a squared and then minus 4a plus 4. The next one will be a squared minus 6a plus 9. The third one would be a squared minus 8a plus 16. Well, that's 4a squared. This is 30. And if I add up the middles, I get 10, 20. I get 20, negative 20. Boom, there's my answer. How could I have cheated? Let's make up a number for a. And let's go over to our calculator. So we go over to our calculator, and we say, okay, I'm going to take 5 and stow it into a. Alright, then I just go to my crazy button here, I find the summation, and I say, okay, n 1 4 parentheses, what was it, a minus n squared, and hit enter, and whatever, I came up with 30. Alright, I came up with 30. So now I'm just going to check my answer. My answer was 4a squared minus 20a plus 30. Come up with the same answer. So you can use some of your own numbers and some simple test taking strategies to triple check to make sure, yeah, I got that right. I nailed that problem. All right, kids, that's it. That's part 1, problems 1 through 14. Come back, we'll do the second half. Keep working hard. If you get 100, email me, kenkrause@gmail.com. Also hit the subscribe button. Get some subscribership up. All right, guys, have fun storming the castle. Goodbye. Goodbye.